Now the question is, how do we express the principle of inclusion and exclusion with 3 sets? I want you to recall 2 sets. Okay, it's a simpler, or it's a more simple Venn diagram. This is A, and this is B. So if we wanted to find the number of elements in A union B, so all in here and all in here, what we would do is we would say the number of elements in A plus the number of elements in B minus the number of elements in the intersection, because those have been counted twice. But when we're dealing with 3 sets, the Venn diagram gets a little bit more complicated. So I'm going to call this A, B, and C. So if we want to find the number of elements in A union B union C, so in this whole kind of 3-circled figure, I would take the number of elements in A. What I'm going to do is I'm just going to check mark all the parts that are being counted currently. Okay, so the number of elements in A. This is the check marks are going to help us find out which have been double counted. Like this intersection here gets double counted when we find the number of elements in A plus the number of elements in B, so we have to subtract off the intersection. These check marks are going to help us figure out what we need to subtract. Plus the number of elements in B, so that's this one, plus this one, plus this one, plus this one. So you'll see they're being double counted right now. Plus the number of elements in C, so this one, and this one, and this one, and this one. So you'll notice that we have these portions which are double counted, and this middle portion is actually triple counted. So we need to subtract the number of elements in A intersect B. So I'm just going to erase the elements that we're subtracting away. So every single portion should just have one check mark at the end of it. So this one right here, and one of these guys here, minus the number of elements in B intersect C. So that's going to be one of these. Oh, not both of them, just one of them, and one of these. Because this right here is the intersection of B and C. Minus the number of elements in C intersect B. Okay, so that means that that's this shape here. So we're subtracting one of the check marks here and one of the check marks here. However, now that we've subtracted all of these intersections to get these to be single, we now don't have any way of counting this middle piece. So what I need to do is go back in and add the number of elements in A intersect B intersect C. That's where all 3 intersect. So at this point now, every single portion of this Venn diagram has been counted once. So this right here is the equation that we will want to use for the following question.